Okay, welcome to Engineering Solutions. Today we are looking at conditions necessary for a rigid body to be in equilibrium under the action of non-parallel forces. Last week we did when parallel forces are acting on a rigid body. So let's do a recap on parallel forces before we move to non-parallel forces. We have a uniform bridge on the board being supported by pivots A and B, and as we can see, a load of 5 Newton is resting at the 75 centimeters mark, and there is the total weight of the bridge, 3 Newton, the weight of the bridge acts at the center of gravity. And we are asked to calculate the reaction at A and reaction at B. So reaction at the supports A and B. Okay. The total length of the bridge is 100 centimeters. From the principle of moment, the first principle, it states that when the body is under equilibrium, when parallel forces are acting on this body, then the sum of all upward forces should be called the sum of all downward forces. So I have the reaction at A, summation upward forces should be equal to summation downward forces. So the upward forces have RA plus RB. Downward forces 3 Newton plus 5 Newton, give me 8 Newton. Okay, call this one equation dada. Now, the second principle, it states that sum of clockwise moments, when we add all the clockwise moments, should be equal to sum of all the anti-clockwise moments. Moment mathematically is defined as the force times perpendicular distance. We can take moment at A or B. Taking moment at A means that we are removing the pivot A, and when you take off the pivot A, it means that all forces will act towards that junction. So the force here will move towards that direction. The direction of the force will determine whether it is moving clock or anti. So taking moment at A, A means I'm removing the pivot A. Then the bridge will collapse. So left with only support B. Support B, pivot B will be there, the bridge will collapse. Then it means that all the forces on the bridge will move towards where the pivot has been taken. So the movement will determine whether the direction is clock or anti. But note, immediately you take off the pivot, then it means there will no more be reaction at that junction. So taking moment at A, there is no more reaction at A. So direction of all forces towards A. You can see that there is a force here, RB, it will move towards A. So RB will move towards A, and the direction will determine whether it's clock or anti. So this is anti-clockwise, label it A. We have another force here, 3 Newton, moving towards A. So direction, you can see that it is clock, so label it C. We have another force here that will move towards A, the direction clockwise, so label it C. The same way, if I take moment at B, it means I'm removing pivot B. Then all forces will move towards B. So it means that RA will be there, no more reaction at B, because I've taken moment at B, moving the pivot B from there. All forces will move towards B. It means that RA will move this way, that will be clock. This force will move this way, that will be anti. And this force will move this way, that will be anti. So whether you take moment at A or B, you should get the same answer. Okay, so I'm taking moment at A. So the direction of the forces, so summation clockwise moment from the second principle should be equal to summation anticlockwise moment. Okay, so the clockwise moment, I have the 3 Newton moving towards A. If the total distance of the bridge is 100 centimeters, and there is the center of gravity where the total weight of the bridge at, then it means from the end here to the center is 50 centimeters. But you can see the pivot was placed at the 5 centimeters mark, leaving here 50 minus 5, leaving this side to be 45 centimeters. Okay. The weight 5 Newton is resting at the 75 centimeters mark. If from the end here to where the weight is 75, and I know this side is 50, means that from here to this end is 25 centimeters. Okay. Clockwise moment, I have here clockwise, the first and perpendicular distance is perpendicular, angle here 90, the distance. So power forces acting on a rigid body under equilibrium. 3 Newton times the distance 45. So I have 3 multiplying 45 plus 5 multiplying the distance this will move towards A. The distance is 25 plus 45 before it will reach A. So that would be 70. So it will be 5 times 70 equal to anti-clockwise moment. I have only one anti here. Remember when I took moment at A, there is no more reaction at A. So it was left with B, and the reaction at B will move towards A. So the distance B will cover to A. Looking at the distance, to move from here to A, I know that here to this side is 70, 45 plus 20. I'm left with a small distance here. And as you can see, the total length of the staircase 100 centimeters, the beam 100 centimeters, and the pivot was placed at the 85 centimeters mark, pivot B. From here to the end here is 15. So 75, when I add 10 to it, making it 85. So that means the distance from here to here is 10 centimeters. So for reaction at B, the distance to move to A will be 10 plus 25 plus 45. That will be 80. So the distance, total distance, perpendicular distance, RB times 80. Okay. So I'll have 3 multiplying 45. 3 5 15. So 135 plus this 350 equal to 80 RB. Okay, so adding this to this, I'll get 485 equal to 80 RB. So divide here by 80, this side by 80. RB will go into this, that will be 6.06 Newton. From equation data, I can find my RA. So substituting RB 6.06 Newton into equation data will make, so from equation data, it means that my RA will be equal to 8 minus 6.06. Which will give me 1.94 Newton. Okay. So this is the reaction for A and B. So reaction at B is 6.06 Newton, reaction at A is 1.94 Newton. So note, taking moment at a particular pivot means that there will no more be reaction at that pivot, and all forces will move towards that pivot. then you apply the principle summation upward forces equal to summation downward forces. That's the conditions necessary for a rigid body to be in equilibrium when parallel forces are acting on it. Now let's move to conditions necessary for a rigid body to be under equilibrium when non-parallel forces are acting on it. When non-parallel forces are acting on a rigid body which is in equilibrium, then we need to resolve the distances into perpendicular and then the parallel conditions, or what we call the horizontal and vertical components. Okay, so we have a question on the board. We state that we have a uniform ladder, 10 meters long, which is resting on a rough ground and against a smooth vertical wall. Okay, and this stick is inclined at an angle 30 degrees to the vertical, and we are asked to find the normal reactions at each end of the ladder. So this question is under conditions necessary for a rigid body to be under equilibrium when non-parallel forces are acting on it. So I have a ladder this way, and the total length of the ladder is 10 meters, and the weight of the ladder and the total weight of the ladder will act at the middle. So the weight of the ladder is here, 100 Newton, resting on a rough horizontal ground. So the ground is rough, meaning frictional force will be there. So there is the ground level rough, and it's leaning against a smooth vertical wall. The wall is smooth this way. It is inclined at an angle of 30 degrees to the vertical. So the angle here is 30 degrees to the vertical. Okay, this is 90. And we are asked to find the normal reactions at each end of the ladder. So the ladder here will exhibit an upward force this way. So let me call this one reaction at this point, say reaction at A, and this N2. So normal reaction, the normal reaction is always perpendicular to the plane. So it should be perpendicular at an angle of 90. So we call this one reaction at B. Okay. So now, to be able to get the reactions at A and B, then we need to take moment at that A or B. So taking moment at A means that there will no more be reaction at A, and all forces are going to move towards what? A. Okay. I have a force here, 100 Newton, another force here, RB. Now, the perpendicular distance to the ground level will be this side. As you can see, the perpendicular distance will be here. No, moment is force times perpendicular distance. And the ladder is making an angle of 30 degrees. So to resolve the distance here to both vertical and horizontal components, as you can see, there is the adjacent and there is the hypotenuse. So to find this side will be 10 cos, or like cos 30 degrees equal to the distance here, say y. So y over the hypotenuse, which is 10. So y will be equal to 10 cos 30 degrees. Okay. So taking moment, the second principle, taking moment at A means that the forces will move towards A. So I have a force here moving towards this junction A, and the force there is RB. So RB multiplying the distance. The distance it is going to cover is 10 cos 30. So multiplying 10 cos 30 degrees. Okay. Then I have another force here, 100 Newton. And this 100 Newton will move towards A, anti. So this is anti-clockwise, this is clockwise, this is anti-clockwise. So sum of clockwise moments, so summation clockwise, anti-clockwise moment, summation anti-clockwise moment should be equal to summation clockwise moment. So first here, the distance will cover to A, that will be 10 cos 30. So RB times 10 cos 30 should be equal to the clockwise moment, the distance from here to this side. Okay. As you can see, if here is 30, 90, total angle in the triangle here will be 60 degrees. Okay. So if I want to find the distance from here to this side, so the distance it will cover. So 100 Newton multiplying the distance. Note, the weight acts at the middle of the ladder. So if here is 10, then the middle will be 5. So assuming this is x, and I'm solving for the distance here, the angle here is 60. So cos 60 will be equal to the adjacent, which is x, over the hypotenuse, the division of the total length of the ladder, 5. So s will be 5 cos 60. The distance it will move towards a perpendicular distance. No, the distance should be perpendicular. That's why I'm resolving it. So 5 cos 60 will give me the distance here. So 100 times 5 cos 60 degrees. Okay. Making RB the subject. So RB will be equal to 100 times 5 cos 60 over 10 cos 30. No, cos 60 is half. Half multiplying 5 will give us 100 times 2.5 over cos 30 is 0.866 times 10 will give us 8.66. Give us 250 over 8.66. 250 over 8.66 will give us 250 over 8.6 will give us 28.87. 28.87. Okay, so that will be the force at RB. Then the first principle will come in. Summation upward forces should be called summation what? Downward forces. Okay. So we have the upward force here, RA,